Hi, my name is Ray Daw, and this is my Lab 1 draft. So, just to get going into what we did and a little bit of the concepts we use, the goal of this lab was to find the excess charge on a piece of tape after it had been pulled off of another piece of tape. And basic concepts we used were the electric force formula, and then, of course, um, that comes from the electric field formula, the electric force formula that we used to find the force on a piece of tape, and thus the charge on a piece of tape was the formula below, which is force equals 1 over 4 pi epsilon naught, um, charge squared over the distance between the two tapes. And so how we did this was we measured where the hanging tape is first repelled by the tape that we are holding under it, and we do this by finding where the tape first starts to show signs of motion as the second tape is under it. And so then once I found the distance, I calculated the force of gravity on each piece of tape, which came out to be 1.56 newtons, as gravity is 9.8, and the mass of the tape was 0.16 grams, and I think the tape was about 8 centimeters long. And then what I did after that was I solved for QB, or because what I did was set the force of gravity equal to the electric force, because at that point was where it started to repel, which means this is when force of gravity and the electric force were about equal with each other. So using that, I could solve for the unknown, which is the charge of the tape. So the results I got from that was negative 3.7 times 10 to the negative 10th. And with that, I could find the number of excess electrons by dividing the charge by the charge for 1 electron. And then we could also solve for the ratio of excess electrons to total atoms by finding the total atoms on a piece of tape using the area of one atom, and also by knowing the area of a piece of tape. Quick assumption we made there was that the tape had no thickness, so it only had an x and y dimension and not a z dimension, just because the tape is so thin. So we did not account for that. So that's one assumption we make. Then the ratio of excess electrons to total atoms we found was 9.7 times 10 to the negative 6. So here's the code I made for the experiment. And really it just went back over sort of what we just did. As you can see, I created 2 tape objects as well as a table object, and the tape was 0.03 millimeters apart, or no, 0.03 meters apart. And I did the calculations exactly like I just described, setting the force of gravity equal to the electric force, and calculating the charge from that being the only unknown. And then I just created arrows for the force of gravity and also for the electric fields on or at the positions of each of the pieces of tape. And again, another assumption I had to make here was that the tape was just a point charge instead of a flat sort of rectangular surface. So on the next slide, you'll see that it is just the 2 tapes are just dots in space. So here's what the program turned out to run. The 2 Red arrows are force of gravity, each pointing down. The red ball at the bottom is the table, so you can sort of see how far off the table each piece of tape was relative to how close they were to each other. And also the blue arrows are the electric field at the point. So the reason they point towards each other is because the tapes are negatively charged, and the electric field at a point is assuming that that point is positive. So on tape 1, which is the upper tape, it's pointing back towards tape 2, which is the lower tape, because if it was positive at that point, it would attract back to that charge. So if you calculate the force, which is just opposite of the gravity, the force of gravity, it would actually point the opposite direction of the electric field. So if the tapes, or actually if electrons and protons were to switch places, electricity and attraction and all that would still behave relatively the same, because you'd still have positive and negative charges. In this case, the direction of the electric field would change, but the two pieces of tape would still repel each other if they were positively charged instead. So yeah, that is about it.